Hello friends, welcome to Daring Marina YouTube channel. Today we will be discussing about safeties in the main engine. Okay, let's discuss. So mainly crankcase safety. For a crankcase safety, relief valve will be set about 0.05 bar. If excess pressure came, so crankcase relief valve will get open, the spring will get activated, excess pressure will be relieved. Then oil limit detector, that should be set at 2 to 5% of the lower explosive limit. For the crankcase, oil mist detector should be present at different points and they should be set at 2 to 5% of the lower explosive limit, and temperature sensing probes on bearings and thrust block which will shut down the engine. There will be temperature sensing probes that they can be seen at bearings, thrust blocks. If the sensor activated, they will shut down the engine. Then other safeties are flame, spark arrestor, deflector. These can be incorporated in the relief valve. Okay. In the scavenge safeties are sight glass, drain cocks for monitoring leakage, temperature sensing probes, fire extinguishing medium, fire extinguishing system. Then relief valve. Here relief valve is 1.6 bar. If in the case of a BMW engine, depends. We should look in the proper machinery itself. For the cylinder head, the safeties are relief valve, non-return air start valve, pneumatic operator starting air valve, and these will be get shut by cylinder pressure once the engine fires. In the exhaust manifold and trunking, the safeties are fire extinguishing system, drain cock, test cock at individual units, flame and spark arrestor, protective grids, and bellows before turbine. And exhaust drain cock in the trunking of the exhaust gas boiler, drain cock at turbine housing to make sure that there is no water coming into turbine, manometer at inlet and outlet of the exhaust gas boiler, and the safety valve. These are the exhaust valve safeties. Then piston cooling system, their safeties are low pressure cutout, usually approximately 2 bar, high inlet temperature, they will slow down alarm at 60 degrees Celsius and shut down at 65 degrees Celsius. Then low level alarm in cooling water drain tank, sight glass at every unit with a piston cooling non-flow alarm. Then jacket cooling system, low inlet pressure shut down at approximately 2 bar, high outlet temperature slow down at 90 degrees Celsius and alarm at 85 degrees Celsius. Low level alarm in expansion tank, sight glass in expansion tank, air separator and vent. Then lubricating oil system, that means sump level low and high level alarm, main lube oil pressure low level alarm at 2.2 bar and shut down at 2 bar when the pressure comes down. Then lube oil outlet temperature, that means at 50 degrees Celsius and they will slow down at 55 degrees Celsius. Then relief valve at discharge side of both pumps, contain discharge side, back to suction side. Then pressure gauges at after cooler and after discharge filter. And differential pressure low alarm, air vent at cooler, air vent at discharge filter. For a fuel oil system, the safeties are drain at service tanks, settling tanks, filters, mixing column, heaters, and relief valves at booster pump discharge, heater, common inlet manifold to pump, and on the individual fuel fill. Then fuel high temperature alarm should be set at 120 degrees Celsius. Low fuel temperature will be set at 85 degrees Celsius. Viscometer, thermometer, and pressure gauge will also fitted for fuel oil safety system. For starting a system, safeties are in the starting a system for the air bottle. The safeties are relief valve will be set at 32 bar. There will be fusible plug, drain cock and pressure gauge, non-return stop and isolating valve. For an air compressor, the safeties are low pressure, that means first stage and high pressure second stage relief valve. There will be low pressure first stage and high pressure second stage relief valve. Non-return valve at compressor outlet to air bottle. Then non-return valve, usually angle valve at the compressor outlet to air bottle. Corrosion resistant bursting disc or relief valve in the cool down water side. Then air discharge high temperature cutout, cooling water high temperature cutout, low lube oil pressure cutout. For starting airline, the safeties are flame trap, bursting disc cap or relief valve, automatic shut off master valve, non-return starting air valve, drain cock in manifold and other parts, on drain cock before the shut off valve, temperature pressure sensor of engages, running direction and turning gear engage interlock to prevent starting. For a control air system, the safeties are pressure reducing valve, oil separator and moisture separator, control air dryer, manual and auto drain, relief valve, pressure sensor probe for alarm at 6 bar and shutdown at 5.5 bar, low pressure alarm for spring air to exhaust valve, and exhaust valve actuator, automatic air venting unit. For a cylinder lubrication, safeties are down flow and slow down. Then when we look at the leaky starting air valve, what will be safeties provided during at port to check whether the air start valves are leaking? We have to disengage the turning gear and shut off air to distributor, so that after this indicator cocks to be opened, take each unit to TDC and check for air coming out of the indicator cock. With the main air bottle from bottle open, admitting start air to engine, the engine does not turn on air since the air to distribution is shut. So, but as a safety measure, in case of leaking starting air valve, turning gear has to be disengaged. At C, how we will check is, feel the start air inlet branch pipe for each unit and see if they are hot. If the engine failed to start because of a sticking pilot or air start valve during maneuvering, then give a kick in the opposite direction so that start air is now admitted to another unit. In case of a generator engine, manually turn the engine to get it off the blind spot. For a starting airline explosion, what the safeties are? This is mainly due to accumulation of oil or due to carry over of oil from starting air compressor. A defective starting air lane on the cylinder head provides heat if it leaks back to the starting air lane. For the preventions are, we have to do good maintenance of the air compressor, auto and manual draining of water and oil in the air lane, starting air manifold pipe should be inspected and cleaned, starting air valve should be overhauled at regular intervals. Then safeguard against overspeeding. For slow speed main engine, speed is sensed by digital pickup similar to induction pickup. If engine speed is increasing, fuel rack will shut down. In case of Sulzer engine, there is a collapse link is fitted between governor and fuel rack. In BMW engine, puncture valves are fitted on top of each fuel pump, which fills the high pressure oil back to suction side of pump. In medium speed auxiliary generator engine, flyweights using centrifugal force that will activate to stop the cylinder to push back to the fuel rack. These are the safeties in the main engine. Thank you.